Welcome to Maths with Bob. Today we're looking at a bearings and trigonometry combination type question where a boat's sailing basically on a couple of different bearings and you need to find its distance from its starting point and some bearings on either direction from the starting point to where it is and from where it is to the starting point. So I suppose the first thing we always do is try and draw up the situation. So I think the best thing to do is obviously first of all draw a couple of crosses, okay, north-south. Now we're going to sail on a bearing of 140, so we know it'll probably be down here somewhere. Okay, and then we're going to go on a 250, so we're going to come around over this way somewhere. Okay, so first thing, it's not terribly well drawn. Let's just straighten that up a bit. Okay, so this one, okay. Okay, so these should be north-south, like a compass type situation. Oops, hold on, what happened there? Okay, here we are. Right, okay. Okay, all right, so obviously let's have a quick look. Obviously this is north, and obviously these are all north. So these are all parallel. That's one of the great things about these sort of problems. All the norths are parallel, okay, and so we're going to go on a bearing. So let's see, where are we going to go? Well, we're going to sail on a bearing of, as you can see here, let's have a look. Let's just make it purple here, that's okay. Okay, so we can go on a line really, well, let's see, just do it dotted for the time being, to here, and then down to here. Okay, and then we basically have got to try and find out how far it is from the starting point back to here. Okay, so the first thing is, okay, we just draw a little graph of our, if you like, trip on the boat. Well, we didn't actually go back to the starting point, but that's the distance. So, okay, so let's mark in first for a start distances, 40 kilometers here and, okay, 80 kilometers here. Now, we know, let's have a quick look. We know that 140, okay, we know it's around here. This is 140 in here, okay. So that's 140, and the other one is 250 around here, okay. But rather than write those, we're just going to write the actual little angles, okay. So let's actually just write in, okay, so we know if that was 140 around, we've gone, say, 50 degrees past 90. So let's just write, say, 50 degrees in here, and then we automatically know that that'll be 50, okay, because the east-west lines are also parallel, and they are alternate angles, okay. Now let's have a look at, let's actually, while we're here, let's actually mark these points. So this was the original starting point A, then we sailed to B over here, okay, and then we sail down here to C. Now, we didn't sail home yet, but, okay, oops, C. So that should be point C down here. Okay, all right, so obviously we need to find X. Okay, X is the distance from A to C, and we need to find some more angles. Okay, so let's have a look. Now, you might remember, okay, so this is 250. So it's 250 right around there. Okay, so we know that 180 is to here. It's coming to, that's to 180. So we know that we must have gone, okay, 70 degrees further past. So we know that, let's have a look. Let's mark some angles in. Okay, so we know this would be, say, 70 degrees here, or if you like, 20 degrees there, because we know that, okay, we have well, each quadrant's 90 degrees. And then we also know it would be 20 degrees down here as well. Okay. Now we're going to have to find some angles, some bearing angles, but let's first of all just try and find out what X is. And you might remember this is the cosine rule. So what is X? So part A, what is X? Well, we know that X squared is equal to 40 squared plus, okay, 80 squared, okay, the sides about the angle squared, okay, minus 2 times these sides, 40 times 80 times the cosine of the included angle, in this case, which is, okay, here is just 70 degrees, okay. So we need to work that out on the calculator, okay, and you can see once we do this, we get x squared is about 5,811. So basically, you have to be a little bit careful. Remember, okay, x squared. So we actually find out, this finds the square of the distance. Okay, roughly 5,811.07, so approximately. And therefore, x is obviously equal to the square root of this value, which is about 76.23 kilometres and that is to 2 decimal places. Okay, so the first part, finding the distance, is an application, if you like, of the cosine rule, which was not too bad. Okay, we just have to find some angles. Okay, now we're going to have to try and work out the bearings. Okay, so let's actually see how we're going to do that. Well, okay, let's have a look at part B now, finding the bearing of C. Okay, now where is C? Okay, so we're going to find the bearing of C down here, okay, from A. Where's A? A is up here, okay. So we have to find the bearing of C from A. So we basically need to find this angle here. Okay, that is the bearing of C from A. Now we've already got 50 degrees, so we've got a bit of it. Well, we really need, okay, and we know that that's 90 there, so we've got 90 and 50. But we need this bit here, okay. So we need that angle in that corner. And we've already found x, which is the distance AC. So we can actually use the cosine rule again. So let's actually just put in, say, let's put alpha. Let's put alpha. Okay, so basically we want to find alpha here. Okay, how big is alpha? And we just have to add 90 and 40 to it, okay, to get the bearing line. Okay, so what would alpha be? Okay, this is, as you can see here, well, an application of the cosine rule again, but it's the angle version, so we need to write down, okay, let's write down, okay, B. So what is the cosine of alpha? Now you might remember that's always, as I say, always, you can always write down minus 80 squared. You're always taking off the one opposite it squared. And you know it's, x squared plus 40 squared. Now, x squared, as you know, is AC, so that's actually just AC all squared. We've just found that, and we can type that in, and then it's going to be 2 times, okay, x times 40, okay, the side's about the angle. Okay, so we need to basically, when we do this, we end up getting that actually cos alpha is basically about 0.1657, okay, approximately, and obviously we have to go shift cosine, so to get the alpha out, we obviously need to go cos to the minus 1 of the answer, this value, 0.1657, okay, and basically this works out to be about, to the nearest degree, it's about 80 degrees, 27 minutes, so to the nearest degree, say it's about, so let's say it's about 80 degrees, okay, approximately, this is to the, okay, nearest degree. Okay, so what would our bearing be then? Okay, so we now know that that's 80, so we just have to add all these angles up. Okay, we've got 80 plus, well, 100, I suppose you could just say 140, if you like, plus 80. So it's going to be about 220 degrees true. Okay, so basically, okay, this bearing here, well, this bit was, what, 140, this bit's 80, okay, so the bearing line will, okay, be about 220. So let's just answer part B, okay. So the bearing, after we've worked all this out, we end up getting that the bearing will be, okay, B, okay, the bearing, okay, is, say, 140 plus 80, which is, 220 degrees true. So this is the true bearing of C from A. Okay, now we are going to have to work out another angle. I'll just put it in here as well, theta. Okay, we're going to need this angle in here as well, basically because we need to find the bearing of A from C. Okay, we now need to find the bearing of A from C, and you can see here, obviously, we're basically based here at C, and we're looking up to A up here. A is up here in this corner up here. So we're going to try and find the bearing line. Now, the bearing line, as you can see, is basically this one here. This is the bearing line up here. So we need to really to find that angle there. So we need to work out a way to find that little angle there. Well, we do know the total angle is 90, so we're going to have to come up with a way to try and work that little angle there out. Okay, so and that would be the bearing line. So the bearing, let's actually put it in as a for beta. So make it beta. So beta is basically going to be our bearing, this one here across there. But we are going to have to find out theta first. Okay, so we are going to need to use the cosine rule. So for C, okay, we're just going to go what is cosine of theta? Well, you can see here it's always going to be, okay, minus 40 squared. Okay, and that's going to be, let's write it in as AC squared, okay, plus 80 squared all over 2 times AC times 80. Okay, we're going to have to work that out, and that works out to be roughly, let's have a look, 0.8 699. 8. Okay, 699. That's cos of theta. Okay, and obviously theta, okay, is going to be cos to the minus 1 of this value. Okay, 0.8699. Okay, and to the nearest degree, that works out to be 29.54 degrees, or 29 degrees 33 minutes. So we're going to say this is about 30 degrees, okay? So this is about, say, 30 degrees to the nearest minute. Oh, sorry, nearest degree, okay. Nearest degree, okay. Okay, so it's about 30, so that's theta. So theta's about 30 in here, okay. And you can see here that we can just work out beta fairly easily from that. We just have to take, what's that, 30 and 50 from 90, and we can see that the bearing is going to be about 40 degrees true. Okay, so let's actually just write that. Okay, well, let's just write that. So, okay, what is beta? Well, beta is equal to, you can see here, 90 minus 30 plus 20. Okay, so it's about 40 degrees true. Okay, so the bearing, if you like, sometimes if you want to do it as a 3-figure bearing, 040 degrees true, but it's actually basically just on the bearing line of north clockwise 40 degrees. Okay. Well, thank you for watching, and we'll see you again shortly. Bye for now.